This is question 2 on problem solving from the 2016 IMAT. So we're told that making a product in a factory requires these 9 different operations, which take this much time each, and all of these must be complete within 16 hours. So the factory workers can do one operation at a time. Therefore, in this 16 hours, what is the minimum number of workers that's required? So ideally, how would we split this up? Well, we want as few workers as possible, each doing a full 16 hours with some combination of these operations. And so let's see how close to this we can get. So if we start with our biggest number, that's 12 hours. What do we have to match this with to make 16 total? Do we have any 4s? Well, yeah. So one worker could do 12 hours plus 4 hours. That makes 16 total. So what about our next worker? Well, our next biggest number is 10. And so do we have any 6s? Yep. So that makes the full 16. So we've got 2 workers working the full 16 hours, which looks pretty good so far. Then what's next? So we have another 10. So we can't add 8 or 9, but we can add 3. And that makes 13, so we can still add this 2-hour job as well. So the worker is working for 15 hours, which isn't perfect, but it's still pretty good. So what does that leave us with? Our only jobs remaining are one 8-hour and one 9 hours. So can we have one worker doing both of them? No, because that would take 17 hours total. So they have to be done by separate workers. So that's all of our jobs done, and we've used 5 different workers, which looks okay, but can we improve it at all? So let's try and rehash our workers with different jobs. So maybe if we start with 10 this time, we can add the 2 and the 4-hour job to him to make 16 hours total. Then we have the other 10, and we know we can add a 6-hour job to that to make 16 hours. So if we now take our 12, what can we add to that? So our only option is 3. So again, our third worker is doing 15 hours. So it looks like we're going down the same route. Then indeed, we just have our 8 and our 9 left. So again, we're using 5 workers, and we've tried to be as cunning as possible by making the workers work as long as possible. So it looks like 5 is going to be our minimum number of workers. So we've checked this in 2 different ways. So it looks like this is going to be our final answer, which corresponds to E on the question paper.